So if you look at the title, the efficient way of auto-scaling your workload in Kubernetes, of course, we're going to talk about Kubernetes. So we're in a testing room, but you will see that indirectly I will talk about testing in some way, because for this presentation, I'm really happy that I'm not delivering a demo, because with this mic it's going to be very difficult. I do a lot of screenshots, I do a lot of testing to provide you some numbers. So behind the scene, there were a lot of tests. So let me shortly present myself. My name is Henrik. Rex said I am a cloud native advocate working at Dynatrace. And prior to Dynatrace, I've been spending most of my career as a performance engineering. So I like breaking things. I like to tune things. I like to optimize things. This is my passion since so many years. And that's why when I still have the time, I try to produce content for a podcast that has been now shifted to a YouTube channel called PerfBytes. So if you're looking for content for performance engineers, check it out. It's out there. It's free. And we just talk about performance methodology, and so on. And then 2 years ago, I started the adventure of launching a YouTube channel called Is It Observable? It's only about observability, I'm mainly talking about open source solutions, concepts. It's a young channel. Again, to improve the content, check it out and send me your feedback so that I can change my content and adapt my content. So, what are we going to talk about? Well, let me bring you to a story. So it's going to not be a fairy tale, but almost. And this fairy tale is going to be about, of course, Kubernetes. Behind the scene, I mentioned there will be a Kubernetes cluster, and we're going to talk about money. Yes, money. I know sometimes some people doesn't like to talk about money. We're going to talk about money, but maybe if you don't like about money, keep things that if we optimize the costs, then we're going to be green because we will consume less energy in the cluster, and then we will be engineers that are thinking of sustainability platforms. So again, don't only think about money, think about energy saving behind the scenes. So in this talk, we're going to talk about the cost of our environments. And we're going to see that we are going to try to optimize a cluster based on cost. And we're going to see what the impact actually of wrong optimizations that will happen on our cluster. And we'll see that once we find the right settings that we need, we will probably need some auto-scaling. And that's why we're going to introduce HPA. So for those who never heard about HPA, so Horizontal Pod Autoscaling, I'm going to remind what it is. And we will see how to configure them. And last, we will see that there's a limitation behind the scene with traditional HPA. And let's figure out a way of being more efficient. All right, are you ready? Oh, that is small, yeah. All right, so once upon a time, here we're talking about a team that is building a solution, a website, a public-facing website. So I'm not going to share any names of any company here, but this team was building, testing, producing the app, and once they ship it on production, the traffic was not so high, so it didn't have much peaks. But the version of the app that they delivered was quite stable, reliable, and everything was performant. So everyone was happy about it. So that brings us to the fact that because we are awesome, we can start innovating and bringing new features, providing new awesomeness to our customers so everyone is happy and we can make even more business. But someday, someone knocks at the door. I'm not going to mention the role of that guy, but the guy says, "Okay, guy, you did a great job, but we're looking at our cloud billings, and you guys, we need to optimize a bit the cost." So it's not an urgent feature that I'm asking for you guys. Keep in mind, try to optimize it. All right. So as a side project, try to find a way of reducing somehow the footprint that we have in our cloud billing. All right. Sure, let's do it. So to do that, let's remind us how is the cost, how the cloud providers are charging the costs within our clusters. So if you look at the Kubernetes cluster, because here it's a app deployed in Kubernetes. It's like an onion. So you have the cloud provider that provide a lot of features. And then you have the cluster itself. And within the cluster, of course, you need nodes, so physical machines or virtual machines. And then depending on how your application works, you probably need some persistent volume claims. And you will also obviously have networking. So the way the costs is charged from the cloud providers, I mean, you know it. I'm not going to reveal any secrets here. The cloud provider will take some fees because they manage the cluster, so they give us the master nodes, so they will take some fees about that. And then if you have nodes sitting on different zones, the traffic between zones will be charged. And last, you have the node itself. So depending on the size of your CPU, the memory, the GPU that involves in your nodes, of course, it will be more or less expensive. And last is the PVC. No, not last, PVC, but then we have last is the network. If you expose your services out of the cluster, you will, of course, generate external IP address, and those will be, of course, charged by the cloud provider. So now I get it. So how can I optimize this cluster? So we have 3 potential areas we can optimize. So first, we can clearly review the size of the nodes. But in our case, in this particular case, we don't want to reduce the nodes. It's been well defined. We just want to have more workload coming in the same cluster. So same node, we don't touch the sizing, that's it. The second thing is persistent volume claims. In our case, we have a database involved. The sizing is fair enough. We don't want to touch it because we want to have a performant database working, so we need efficient disks to provide the right response times. So last is resizing the workload. All right, so what does it mean in the Kubernetes world? Well, resizing the workload means, in fact, that if you know Kubernetes, when you deploy your workload, it will go through the scheduler, and the scheduler then, the first piece is going to look at the node that is able to take your workload, and as a consequence, once you deploy it, the node has some resources, and what we asked for will be allocated. And at the end, if you deploy and deploy and deploy, you have basically allocated a lot of resources. But then there is always a difference between what you have actually asked for and what you're actually using. So in this example, I'm using about 10% of what I requested. So I may say that I'm not efficient. Maybe I can review those workload definitions. So resizing the workload means technically here, let's look at what we actually use versus what we have requested. And as you may know, in Kubernetes, you can ask for something, but you can consume more than what you have requested. And that's why you have limits. So if you are above the request, maybe let's check the limits to see, is the limits maybe too high, so we can maybe be more efficient. So what's the journey about optimizing? Very simple. We're going to first create the baseline. So if you know your production environment, you need to have the baseline in front of you, the numbers. And of course, we're going to use those numbers so we can then do a simulation. So previously you mentioned simulations. This is what we're going to do. We're going to build some test case, run some load tests, get the baseline numbers, and then we're going to go through an iterative process where we run a simulation. We configure first. We configure, we change the numbers, we run the simulation, then we analyze. And then the idea is to improve. Again, there are a couple of solutions out there that do that automatically based on AI called Akamas. So if you want to check it out on their website. But sometimes you don't have the budget for those tooling, so let's do it manually, traditional way. And because I'm a performance engineer, I like to do it myself. All right, so let's have a look at the tools. So for the tools, of course, I need observability, because if I need to optimize something, if I don't have the numbers and I don't have the understanding, then I'm pretty much blind. So I will need a couple of those pillars. So the 7 pillars of observability, I'm going to not mention about them. You know them. Logs, events, metrics, traces, profiling, and exceptions. But in this particular case, I'm fishing mainly for metrics. Metrics is going to be the key component, maybe events eventually. But this is the 2 main pillars that I'm going to use. I'm not fishing for traces because it's going to be application side. Here I'm looking more on the infrastructure level. In terms of tools, I'm going to use K6. And of course, it's written here Dynatrace. So I'm going to use Dynatrace to analyze the systems. So I'm using K6, and there's There's a K6 extension that I've built. Again, I don't maintain it every day, so maybe if someone wants to contribute to that extensions, feel free to do that. So the extension is basically taking the metrics, sending it to Dynatrace, and voila, you got the metrics in Dynatrace, the response time, the hit per seconds, the errors, and we are happy. The next aspect is we want to measure the costs and the behavior of Kubernetes that are related to our workload. So in this specific case, also in this context, I'm using Istio. Istio also extend the level of observability, and I see someone from Solo saying yes, 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 and agree. And so here I'm going to add a couple of solutions back in the background to be able to get more insights. So I will use OpenCost. OpenCost is a CNCF project measuring the actual cost of your workload. It's been driven by a kube cost. Then you have Istio. Istio provides a couple of interesting information because maybe we can adjust the rules based on Istio metrics. And Envoy. Envoy also, of course, provide a lot of metrics. And the idea is that here in my particular case, I'm not going to reveal all the secrets, but I'm using the OpenTelemetry collector that will ingest those metrics and send it back to Dynatrace. And at the end, what I'm fishing for is this dashboard. We call it the efficiency, cluster efficiency, where I'm measuring what I've actually requested versus what I'm using to get a ratio on the top here. And then I have different informations. And one of them is on the middle one here. You can see they have the namespace CPU costs and the namespace memory costs. And that will be one of my things that we'll keep an eye on to figure out. So let's jump into the various results. So first, if you want to play around, as an example, all this presentation took me quite a while to build. So I have a GitHub repo on my own Henrik repo. And there is the Autoscaling workshop. So everything you can start using it and deploying it and testing it on your end just to have fun. And it's always fun to have fun and break things. So check it out. So first, the baseline. So here, the baseline was the first version of the application. We can see that we have on the top, we have the user load. And those slides, you will see it on and on and on during this presentation. So here on the top right, we have the user load. And then we have the actual cost. So we started the adventure with about $9 for that application. You will say $9 is not a big deal. But again, it's just a demo. So don't keep that numbers in your head. So $9 for the CPU usage. And in terms of response times, we can see that we are quite stable into 20 minutes of the test. So, and which means we are about 100 users. That was the main baseline. And in terms of CPU usage, we can see we are pretty good. And then suddenly we dropped. And you will see why we're dropping. There is obvious reasons behind the scenes. So then by doing this iterating process, I touch based on the request and limits on all the various workload. To find the right numbers, and my idea is to find good performance with the right cost. So at the end, I was able to get this, and you'll see, the graph seems quite bad. Okay, I say it could be improved. I agree with you. You can see that the use load is about the same, but here I am at $2.5 the cluster, the CPU requested. So basically, I already have significantly reduced the cost. But the difference is that now, instead of having a stable response time, you can see that we have some, quite bad response times at the end. And we can see that the CPU usage after about 15 minutes or 12 minutes here, it's just dropping and then stable. So there is something behind the scene. So what is the reason behind the scene? And you probably know that. It's going to be related to the resource requested in those workload. So to remind, we talked about requests. The requests that we set in the workload is very important because it helps Kubernetes to play the Tetris game. It takes your workload, and then based on the size of the shape, it will put it on the right node. That's why requests are there. You express it in media core and in memory in the case of the request information. But then you have the limits. The limits is obviously different. The limit is you have a contract with Kubernetes. You have a contract with the host. Memory will be expressed in bytes. So if you do the right load test, you can figure out how much memory do I actually need for this workload. And then based on that, you can define the right value. If the value is too low, what happens is the system will OM kill you, so out of memory killing. So it means your pod will be deleted. And then you have the other limits called CPU, and CPU is a concept which is quite difficult to understand. It's not in core, you don't express it, you express into function timing. Why do we express it in function timing? Simply because in your cluster, we are using containers, and to be able to split resources with our node, you use a concept of C group and CFS. So I'm not going to talk too much on details on that. But the idea is that you have a CPU cycle, which is 100 milliseconds, and then you're telling the system how much time that I consume in that cycle. So for example, in 100 milliseconds, if I put 20, it means I can consume 20 milliseconds, all right? So if I can start working 20 milliseconds, and then suddenly, my limit has arrived, so the system will pause my work. So then during 80 milliseconds, I'm doing nothing, or I'm trying to do things, but I'm being blocked. And then the next CPU cycle starts, and I can redo my work. And the system of doing work, pausing, doing work, pausing, doing work, pausing, it's called throttling. So you can imagine that if you have a system running and you've been throttled, you can imagine that you're not delivering a really good response times. And this is what happened in the previous graph that you saw, where suddenly the response time was really unstable, the CPU was super unstable because you've been throttled. But even if it was throttled, I had a couple of good resources. So I say, let's keep that configuration. I know that I'm not super good, but if I add more replica, then I will scale, and I will be able to take more traffic, deliver good performance, and maybe with a lower cost. Okay, let's go in that direction. So let's scale. So how do we scale? To scale, well, there's a few things. So first, if you know Kubernetes, you have stateful sets, you have replica sets, you have deployments, and when you use those deployments, you can set numbers on the replica. Usually, when you start, you would put 1, but you can define 10, 11, but it's going to be a static replica, which doesn't make sense. So that's why we have HPA. So the HPA will, you put a rule and saying, oh, there is a threshold on a metric, and that once we hit that threshold, then it will add more replica to make sure that we are always under that threshold. And by default, HPA only rely on the Kubernetes Metrics API, and the metric API of Kubernetes only provides 2 metrics, CPU and memory. So again, okay, let's try it. So here. So what should we consider to scale? So in my example, I have the hipster shop application, well-known demo applications. So I'm looking at the services that are critical for my users. And the ones that are very critical for my users are, first of all, I want to make business, so I want to have a checkout, the product catalog, the cart, the shipping, the payment. Of course, if people doesn't pay, it will be a disaster. So those are the services that we'll basically try to consider scaling. And one important aspect of scaling is everyone is forgetting about this, is that your pods takes about 1 minute to be actually available and serve traffic. So don't take random numbers. Consider that the fact that this pod will be actually there in 1 or 2 minutes, and in 1 or 2 minutes, a lot of things could go very wrong, you know? So try to figure out that numbers, and then we don't want to have the domino effects where all your pods is just destroyed because you have too much peaks traffic coming on. So let's figure out 1 minute before we need to scale, what is the actual value of the metric that we're picking. So because we're using only HPA, I'm taking the graph here, and then I'm going to look at the CPU usage, and then I'm going to look 1 minute before. In my case, it was 95% because, you know, you can consume more than your requests. So at 95% with a front-end service, I could do a good job. So let's look at the numbers. So I did the same thing with HPA, with that rule. And so obviously I was able to do more traffic. So instead of 1 hour time frame, I was about, instead of 30 minutes time frame, I have a 1 hour time frame. First, let's look at the numbers. So first, if you look at the cost, we are still under what we actually had initially. So we are 2.24, so quite it's efficient. And then what we can see here is that after about 25 minutes, we got a pretty bad response times. And the other graph that I added here is the number of pods. So we can see that the pod is scaling based on the number of traffic coming in. So it's pretty much aligned. So why do we have this unstable response times? Well, if I look at, Dynatrace or other tools, it will show you that I have high CPU throttling again. So CPU is not the best thing for me. I need to find another metric. And in my case, I'm using Istio and Envoy. I say, oh, why don't I take the number of requests coming in my service? That makes more sense because I can control the throughput. All right. So how can I do that? How can I extend my HPA by taking that Envoy metric? Well, you have two ways of doing it. If you're using HPA, if you want to extend your metric server, then we can use what we call metric adapters. So metric adapters means you deploy an adapter in your cluster, and that adapter will basically so you send a metric to, so that any systems in Kubernetes will send a request to the metric server, and then it says, oh, this is not a metric from that I have, so I'm going to connect to the metric adapter, and it will translate that API call into, in this example for Prometheus, it will send an API call to Prometheus, send a PromQL, get the metrics, and then it will respond back to the metric API. So at the end, it's just a way of connecting dots between the metric API that you have in Kubernetes and any observability solution of the market. So if you look around on the market, today we have Prometheus, of course, because it's a standard, but we also Datadog, but there is no other adapters. And building an adapter, to be honest, it's quite a pain. So the disadvantage also is that usually we don't have one observability solution. We rely on various observability solutions. And you can only have one adapter per cluster, which is quite painful. So that's not the best options. So what else? What do we have to resolve that? Well, the answer for this is that there's an open source CNCF project called Keptn out there. And Keptn released a solution called new version of the project called Keptn Lifecycle Toolkit. And that project is providing you now a metric server. So what does it mean? It's basically taking a metric server in the middle, and then it will connect various providers in front of it. So at the end, if I'm using Datadog, I'm using Honeycomb, I'm using Prometheus, I'm using whatever, with this metric server, I can use those metric store on those observability solutions, which is basically what I was looking for. So and at the moment, if you look at the Keptn repo in GitHub, you have a support for Prometheus, obviously, and Dynatrace DQL, because it's the new Dynatrace standard way of querying the Dynatrace metrics. And then there's a new way of querying the metrics called DQL, where you can cross-correlate metrics, logs, traces with a single query. And I think there's a Datadog on the way as well. So what should I do to take advantage of that? So first, of course, I have the metric server, my deployments. I will need to deploy the metric server of the Keptn Lifecycle Toolkit. And I will have to create what we call a metric provider. So the metric provider will define how Keptn will connect to the API exposing those metrics. So in the case of Dynatrace, the Dynatrace URL and API token. So every single provider has their own way of connecting the dot. Then once I have that, I'm expressing the way I'm going to query that endpoint. So either a PromQL in case of Prometheus. Here it's an example of a metric expression where I'm collecting K6 metrics. But again, I don't want to rely on load testing metrics. Doesn't make sense because in production, I won't have a load test running. So I'm going to use other metrics. And once I have done those two things, then I can create my HPA. And then I can say, this is a Keptn metric. So go ahead and pick it up. And then I can say, I'm going to pick the Keptn metric that I named. And then I could put the value. All right, so now, so which value should I pick? So let's take the Istio metrics. So I'm going to pick the Istio metrics. I looked at the Istio metrics. And again, 1 hour before, at 121 connections on that server, I need to scale. So let's do it. So now let's do it. Okay. Let's do it. So now if I look at the results, I have 1.6, which is fantastic, even better. But look at the response times. Wow. And I say, why do I have that behavior? That's kind of weird, in fact. Simply because you look at the number of pods. So the Y, I need to put the Y because it's the flow. So the reason is that if you look at the histograms here, this is the number of pods. And you can see that it started actually very high because we had a lot of throughput coming in. And then suddenly, because other components were slowing down, those components were receiving less traffic. So at the end, my envoy metrics that I thought was useful was not helping me at all. So but at the end, because it was slowing down, I was not providing the right number of replica. And at the end, when the traffic was completely a disaster, it was basically, there was less workload than expected. So I was quite surprised by this exercise. Again, this is based on a demo. I'm not saying that in production you will have the same results. So which metric should I pick? Well, since the beginning, I know that I'm being having issues with CPU throttling. Why don't I use simply CPU throttling? I mean, that would be the best use case. So yes, this is what I did. So same tests. The response times, you can see we have just a peak here in the middle, but then I'm even more stable than the baseline. So I can support more load with less money. And you can see that the number of pods is quite stable during the hours. So at the end, voila. In my case, in this demo, I found the right HPA rules to get more traffic. So, as a takeaway, I'm going to check the time. So as a takeaway, first, in Kubernetes, one recommendation, put resource quota in your namespaces because you will protect other applications. You know that. Second thing is optimize your resource allocations. Defining the right requests and limits. This is crucial. By the way, there is an open source initiative done by Robusta, which is another solution out there. You don't know it. They provided a solution called KKR or KRR, I think I don't remember, which is a table looking at your numbers and then suggesting you what you should place into requests and limits. That could be a start, but again, you probably going to have more traffic in the future. So testing is always a better way of also finding the right numbers. Autoscaling. So I would say autoscaling is awesome. It works pretty well. And it's more and more stable with the new releases of Kubernetes. But please, CPU and memory, relying on those two metrics, it's a good start, but maybe there are other metrics that will be more efficient for you to keep track on. And last piece is the costs. I mean, I took the example of the cost, but there's other projects like Keptn, driven by the working group on the sustainability working group. So Keptn is a solution that with BPF measure the energy consumptions of your cluster. So if you don't want to use the dollars as a KPI, but you want to use the number of carbon footprint or the number of energy consumed by workload, you can use Keptn instead. So I just took the example of open cost, but just keep in mind, take also another dimension that will drive your initiative on optimizing your resources. So cost or energy, I think, is an awesome way of doing this. Last, before we go to the Q&A, I need to make a teaser and promote my YouTube channel. So is it deliverable? Check it out. It's there. Again, like I said, I did the episode on KubeCost, on Keptn, on Keda, on other solutions. So it's out there. Feel free to watch it. Again, everything can be improved. And to improve things, you need feedback. I'm the one saying it. It's been said on the previous session. So please send me your feedback so I can deliver better content. Thank you. And if you have any questions, I will just be happy to answer all of your questions.
Yeah, thanks for a great talk. I think I still didn't get it how you got to CPU throttling as the best measure there.
Because every time I did experiments, the numbers that I was getting was basically bad due to throttling. So the response time was bad because of throttling. So I was trying to avoid using CPU throttling and I thought, yeah, let's take the number of requests coming in through the Istio for an envoy, for the sidecar proxy of Istio. But at the end, it didn't help me. So then at the end, I say, wait, let's take throttling, because at the end, my limitation is throttling. So why don't I take throttling as a reference? And in fact, it was much better.
And is that available straight in Kubernetes? Okay.
So to get if you use the CA Advisor is a component that is mainly being deployed. So CA Advisor is the way of monitoring. Throttling is going to happen on the container level. So to get that, you need a CA Advisor that usually has been deployed by most of the cloud providers by default. It will give you the time spent in throttling. So you need to calculate to get a percentage of that. I can share the how you can get that ratio. And once you have the ratio, you can say, okay, I don't want to spend more than 50% in throttling, because otherwise it will be very impacted. My workload will be heavily impacted by the throttling.
Nice, thanks.
Do you have an opinion on using Keptn in?
So I love Keptn, to be honest. So Keptn is, so for those who never heard, so Keptn is a way of also doing that approach, autoscaling. Keptn is doing it by just doing the autoscaling piece. So you can remove Keptn and do it. But I think with the Keptn metric, the advantage, what I was thinking is, if you use chaos engineering, for example, Litmus, there is an awesome feature provided. Litmus says, I want to measure the steady state. And for that, it will rely on the metric server of Kubernetes to get the metrics. And so I thought it was very limited to say, I want to rely on CPU and memory. So that's why I want to extend the metric server. So Keptn is great for autoscaling, but it doesn't extend the metric server for other use cases. So that's why I presented the Keptn metric, because I think behind the scene, we can do more than just autoscaling. From the moment we expose metrics are we extending the Keptn, the Kubernetes Metric API.
Hi, I was just wondering if what would you recommend, like with dealing with idle resources that are over provisioned in general? Because there are some clusters, there are some organizations that are paying thousands for idle resources that just be like not allocated and just sat like idle. So I was just wondering, like, what would you recommend to sort of deal with those idle resources?
So I think you have to be aware that from EU, European law, has provided a law from the moment now that every organization needs to expose their carbon footprint usage, and specifically in the ITM environment. So if I don't care, because a lot of company says, I don't care, it works, it's stable, put 1,000 servers, I don't care, I'm going to pay it. But at the end, we need to be, we live everyone on Earth, and we need to be considering the fact that we are warming the planet for just being selfish. So I think just having the aspect of being optimizing just by taking the energy usage is a way of improving somehow the energy and reducing the numbers that they need to provide and expose publicly on how much carbon they're using. So I think I get the idea of over provisioning things, but again, sometimes I have customers saying, I need to add more and more nodes every month on my cluster. And then they have that huge cluster, and I look at the numbers and I say, yeah, but your nodes is doing nothing, in fact. You're just provisioning CPU and you're provisioning memory just because you don't know your app, and you just over allocating resources for nothing. So maybe if you reduce your resources, maybe you won't have to add nodes every month on your cluster, and you will be basically optimizing and taking more workload in your cluster. I don't know if I answer your questions directly, but... First of all, you need to detect those out of resources aspects. So observability, it's been presented a few minutes ago in the keynote. Observability is key to be able to detect that. And again, if from the moment your organizations understand the concept from the moment they are suffering. So if they get an outage due to OM kill or outage due to CPU throttling, then they will consider taking actions. Any other questions? Yeah.
Have you got any advice for autoscaling faster? We quite often find that autoscaling isn't keeping up with bursts in traffic, so we need to over provision just to be able to handle that.
Again, it's a good point. The problem is that you have to measure. One thing you have to do is to measure how much how much time it takes to add an extra pod, and to have that pod actually ready and serving actually traffic. Once you have that, then this is crucial because it will help you to figure out what is the right rule that you need to put in place. Because the idea, there is a lot of I remember when people were using many VMs in the cloud, the cloud providers were providing auto-scaling resources. You can add extra VMs and you will scale your traffic. But again, it's always a matter of the app. Yes, we will have an extra VM, we will add an extra pod, but that pod will never take traffic until, especially if you use Java, for example, it could take almost 2 minutes to get the actual pod available. So you need to be very cautious about that, because otherwise you just add all of pods. And at the end, if you were adding it at the right moment, you were adding less workload, because you're considering the fact that my app is going to take 2 minutes or 1 minute to be there.
Wait for the microphone.
Yeah, time for a pod to become ready is interesting for many reasons. What's the best way to get that measurement and and use it?
Yeah, so first make sure that your development team is adding an endpoint or something to measure the readiness, because there's the Kubernetes rely on readiness probes and health probes. So designing from the moment you build your microservices component, if you already think, okay, what does it mean for my app to be actually ready, or what does it mean for my app to be actually be healthy, then provide the right endpoint. So then you use that endpoint or use that command or use whatever that will determine that you're actually there and you can actually serve traffic. And that is, it's the core basis of everything. If you don't have that, then it's going to be very difficult to move forward.
So I've seen from Kubestate metrics the state of pods, but no measurement of how long these processes are taking, how long pods are in certain states, and it's useful for this kind of but also other things like SLIs for the platform.
So the idea is, the only way is from Kubestep you can measure. You have to filter on your given workload, and then you can figure out. I mean, again, it's depending on how often the metric is being scrapped. But then if you have the testing environment, you can increase the scrapping config to have. In case of Prometheus, to get a much more granular metric collection, and then you can measure. Basically, here it's been. It's been unready, and then here it's ready, and then you can measure the actual time. Or you can basically, if you do a describe, you have that information. You can have it at the bottom, the time where each went from one state to the other, and you can calculate the time, the difference to get the time.
Thank you. One more thing, great talk, and also a great YouTube channel for anyone who hasn't seen it.
Thank you.
Have you tried multi-processes in a container and decreasing HPM utilization in order to scale fast and at least make the container throttable? That actually will decrease the cost.
That's a good
approach.
point. Then the one thing I didn't present with throttling is the fact of multi-threads, because if you have multi-processors running, you will consume more threads, and then the limits that you defined, the actual function timing is not on one thread. It's basically the sum of all the tasks of all your threads. So I think it's always a balance of do I provide valuable performant processes or not. So that's dependent on your system.
But the pod will start fast, better than expected.
Yeah, of course. Yeah.
So have you tried that combination?
In this one, no, I didn't try. But it was a good point. Yeah.